parallel lines. In other words, what they're saying is that this distance from P to P double prime is going to be the same distance from Q to Q double prime. In fact, I probably should have put a green line through that and broken it up and put 2D there. I don't have my green marker readily available, but this distance between Q and Q double prime is going to be the same as the distance between P and P double prime. Why is that? Because we have reflected both these points in one line and then in another line, and the key here is that those two lines are parallel to each other. Another theorem that's similar to that, here we have parallel lines, but in this one we have lines that intersect. And when we reflect a point in one line and then in the other line, then that's the same thing as rotating that point from A to A prime, the amount, double the amount of the angle between those two lines of reflection. So what we're saying here is that if we reflect a point in two lines that are intersecting, these two reflections will be the same thing as if we did one rotation, and that one rotation would have the measure of double the angle between these two lines of reflection that are intersecting. So notice this point here, A reflects over to A prime reflects over to A double prime, and that's the same thing. Let's see if I can do this. Yeah. Let's do it this way. So it's the same thing as if I would have taken A and then held down my finger here, my pencil here on the point of intersection of these two lines. So I could reflect it over the one line and then reflect it over the other line, or I can rotate it in or around the point of intersection of these two lines of reflection. So watch this, it's rotating around and it does not match there, but it does match, or it should, it's supposed to match over here. Okay, and so the I could either reflect it and then reflect it again, or I can rotate it around this point of intersection of these two lines of reflection. So that allows us to do some funky things like this. Here I start out with A, and a little bit confusing. You got to kind of think this through. Okay, where A, oh, that's right, A goes to A prime, and then A prime goes to A double prime. So let's just draw a line going from A to A prime, and notice it's a perpendicular line. It looks, at least it looks like it is, and it actually is. And so what we're doing is we are reflecting point A first in line K. We're reflecting it over there. And then we are reflecting it over line M. So here it's reflected over there. And that's the same thing as if I was to, let me see, get this erased. If I was to rotate this. And here it's easier for you to be able to see. Now that I have a full shape. And it doesn't match. I erased the wrong one. I wrote another one on there. So let's start from scratch. Here is my pre-image, and I'm going to rotate this. Rotate it first. I'm going to rotate it around this point of intersection of these two lines that I reflected it over this line K, and then I reflected it over this line M, and that's the same thing, or the end result is the same as if I was to rotate the pre-image all the way around the point of intersection, and obviously you see it does not match there, but it does match up there. Huh, pretty interesting. So reflecting in two lines is the same thing as rotating around the point of intersection. And that line, or that angle now, see this angle here is 70 degrees, the angle between the lines of intersection, and that's the same, the angle between, oops, that's probably my wife calling, the angle between A all the way over to a double prime is going to be double this angle. All right, I'll let you guys figure that out and do the same thing, same idea over here. See you guys soon.